great, but I believe that you guys can understand that from the perceptron and neural network, weight, bias, activate function, then that includes the sigmoid, ReLU, and hypertangent, and softmax, cross entropy, loss function, backpropagation, multivariate deviation, the chain rule, gradient descent, stochastic gradient descent, the epoch, the overfitting, learning rate. I didn't cover the regularization and dropout. Today I'm going to explain these two. And also today we will cover the convolutional neural network, which is the extension of the neural network as the deep neural network. So first I'd like to introduce the convolution and the image feature filtering, and then the pooling, backpropagation, and so on. So there are a lot of things. So usually it may take several months to cover this topic, but if you do not remember any of this one, it will be very tough to understand the rest of them. Also, I'm going to spend half of today's lecture to review the neural network, because if you understand the neural network properly, surprisingly, not many people actually don't understand the neural network itself, even though they have used a lot of other deep learning techniques. But the deep learning is definitely based on this one. While you are optimizing your neural network or the design your deep neural network, without understanding the fundamental basic of what is the learning rate, or what is the overfitting, what is the stochastic, why do we need the stochastic instead of the gradient descent. So it's just the systemically applied. Then until you got the better result, you try this one. This one is a trial and error, the brute force approach. So today, but over the spring break, I spent really a lot of time. What is the best way for students to understand the neural network? So then sometimes the example, sometimes the code. So last semester I have used the code, but I don't think that works very well. So if you are in a hurry to apply for your project or others, I think that you are able to understand the code. The code itself is not difficult. But what is the meaning of the rate, and why we apply the 0.1 instead of 0.0001 for the learning rate, and how much it impacts? Somebody suggests the weight should not be all zero, but some of them can be zero, but close to the zero. Why? So to understand such a thing, I think the best way is understanding the neural network more theoretically. Okay, so I know some of the students have the allergy to the math symbol, but that is the easiest way and the really most clear way to understand the algorithm. After you understand the neural network itself, it's not very complicated rocket science. It's one of the really simple example of your calculus class. If you already took the calculus class before, I think that's much easier than that. Okay. However, I realized that even I'm going to use a lot of different notation. So each and every page, web page, and textbook, so use a different notation. That is a main problem. Today, I'd like to clarify such a thing, which is based on this textbook. I have used it's 160 page, 100 something pages. It's not that big. It's 150 pages. It's more theoretically explain the neural network, one of the easiest textbook ever I seen for the deep learning. Okay, and also this one is based on the TensorFlow. So I know the TensorFlow 2 was announced, but still TensorFlow, the old version, still used a lot. So it's based on the TensorFlow code. So you can directly understand from the equation to the code. Okay, so I think it's not expensive. Also, you can find. I'm not sure. It's recently the published online whether you can find, but this one is. Today's lecture for the neural network will be based on this one. I modified the notation and explanation. So. Then today we are going to start the second project. You need to continue the first project. Okay, but the second project is, as I announced, after we finish the convolutional neural network today, we will start the autonomous car, which is based on the convolutional neural network. Okay, so I tried my best to cover and provide any pre-processing or the prerequisite of the autonomous car. Even though you do not understand the autonomous car, it's totally fine. Okay, it's ready to go, but the problem how to go. So at that time you are going to train and make your own model based on the convolutional neural network on your laptop or other, then transfer to the car. Okay, then I'm going to grade based on how much accurate your car is, not only the detecting driving. Okay, so then today the problem is I have only the 5 set of the car. So I try to my best to order the 2 more cars. Probably you know right now the UB administrator, they freeze all the budget, so it's not actually the approved. So I cannot get the 2 more cars. So I'm going to keep the 5 out of the 7 teams from the first project, and which means the 2 teams will be gone. So assign the 1 for each, or the 1 team will have the 5 team member. Okay, so we will take care of the later. Okay, first we have data, input data. Like for example, by the way, I upload the PDF file, the updated PDF file. You can use that PDF file. So for better understanding, but the more importantly, please try to understand. Best way is if you can write down one process of the forward, okay, the forwarding the process and backwarding process with your own hand. I think that you pretty much can understand the neural network, including the back propagation and the forward propagation. Okay, so let's say that we have the data x. X is a vector, right? So you can have the, for example, the 1, 0, not 1, 0. So for example, the height, so 5 feet. Then the one of the found, or the something other number, for example, the black, and so on. So this is let's say the data. Okay. So we can say in general. So this one is x. Then the x1, x2, x3 is as a vector. So we are going to consider data as a vector. Plus it has, well, as we have seen in the iris data set and any other data set, it has the feature as well as what? Class. So we are going to use one of the element, one of the feature as a class, whether this is obesity or not. So one is obesity, the other one is not. If you have multiple class, the one comma and the other is active or depressed or non-depressed, you may have another class like the depressed, positive, or the non-depressed, 0. And you have the multiple class. The data has actually our data is like this one, but among them we try to use the feature value, feature vector as the input. So we have the x. So x has, let's say, it can be any number. So some of the textbook use probably x1 through the xn, like this one. So it can be really confusing when you think about the general case, but you should be familiar with such a notation and cases. So in our case, we are going to consider the 3 feature case, like the x1, x2, x3. Instead, in terms of the neural network, we are going to use each data as a node, if you remember. So like the circle indicate the node. So we have x1, x2, x3 elements. It can be the height, it can be weight, it can be whatever. Okay. So I'm not going to too much generalize. If I'm using the too much generalized one, so you forget or you lose such a idea of the theory. Okay, so x1, x2, x3 is our data. Then we have what? Output. we have the output. In this case, we are going to consider two classes. So in terms of the statistics, it's a hypothesis 1 or 0. It's a one case, one class case, whether hypothesis is true or not. But the most of cases we have the multiple classes, like whether this is dog or cat or it's raccoon. What a number of. Sometimes such a classes is huge, 100,000. In case of the natural language processing, how many words? 10,000, 100,000 words can be the class. So in our case, to generalize, we don't want to lose such a general case. So output is a 2-1. So output is represented by the output vector. So actually this output is different from, this class is different from the here. I will show the later. So O has, in this case, O1 and O2, which means dog, yes or no, cat, yes or no, like that. Okay, so this is O1, O2. By processing, so if we are using the single perceptron, like the linear regression or the logistic regression, so we are going to combine, we can define one linear equation, then determine one class only. If you remember, that is the one perceptron. The one perceptron is like this. We determine one of them. This is a perceptron, but this is a multi-layer perceptron, eventually neural network. So we have the multiple classes. It can be any number of them. Then the neural network has the what? In-between layer. So input layer, this is the input layer, and this one is output layer. So we have the input layer, output layer. That is general. It's not only for the neural network, any the machine learning and any the artificial. So we have input data, then we try to decide the output data, output, right? So if you are using the classification based on training, it's a classes. Or if you are using unsupervised learning later, we will see the clustering is a group of data. So that is the output. But in the neural network, we have what? In between hidden layer, if you remember. So we have the hidden layer. So let's say the hidden layer is the C. Sometimes many of the textbooks use H, okay? But in my notation, I'd like to use the Z. I don't know why I have used over the spring break. I have used the C suddenly. So C is let's say this is a hidden layer. So we have the 3 layers. For the hidden layer, how many? We don't know. Okay, that is one of the drawback, one of the problems. So, but mostly it's the same. Sometimes it suggests the same number, and or sometimes the bigger. But we will use the 2 of them. So we try to pretend 2 perceptron, multi-perceptron, but 2 perceptron case. So 3 can determine one, 3 determine another one. So that is the same example as we have seen the last class. Last class I introduced the 2 perceptron, and then each output is combined to the 1 perceptron. So total 3 perceptron cases. But here we try to pretend that one. So we have the 2 hidden layers. So C has Z1 and Z2. By the way, what are they? X1, X2, Z1, Z2, and O1, O2, what are they? It's actually number. Okay? It's nothing but number. Because it is true, the machine learning or artificial intelligence, whatever, we are using digital media, like the computer system. So they are the number. What if I have the categorical data, nominal data, ordinal data, or whatever? We can transform such a data as we have seen in the pre-processing of the data. So these are the number. We have a bunch of numbers. Then eventually after we got this one, the output, that is the end of the classification or the machine learning technique, like the linear regression, to prove the hypothesis, to support the hypothesis and so on. In our case, we try to compare this one with the one. The ground truth. So I mentioned about in case of 2 classes, we are going to use this one, the L. for example, L, so this is L1, L2, L. So whether, for example, the input data is 1, 1, 0. 1 is too much simple. So 0.9 and 10.0 and 2.1. Input is this one, that means the 0.9 and the 10 and the 2.1 and processor. We don't know, not yet. After we process, for example, we got the O1 is 0.9 and O2 is 0.6, for example. Okay? At that time, so actually this data has 1, 0, which means it's a dog, it's a true. Cat is a false. So this is a true. So we have the ground truth. It's not L. In this case, it can be T. So in the lecture note, I said the T. So we have the 1, 0. So we are going to compare this one and this one, this one and this one. Okay? Ideally, if that is true, ideally output should be this one, right? Our whatever the process, so output is 1 and 0. That is ideal, perfect. But if we have this one and this one, so then we are going to find what?
Error.
Error, loss function. So for the loss function, we have seen I think we have one more. The not cross entropy, logistic, the function. Logistic function. That is the summation of the square root. So we have learned the cross entropy, whatever the loss function, then we find the error, the loss function. Ideally, 0, perfect. Okay. So, but if not 0, our goal is toward the 0. Okay. How can we make the 0?
By adjusting the weights.
By changing the setup configuration, which we are called the weight. Okay. Then that is the back propagation. So by changing, go back to this way, then change this value and see whether this is going to 0 or not. Okay? Going to 0, then continue until conversion or the global minimum. So we will see the details later. So here, then this is the 3 layers, the neural network. So 3 layers, we have the input, output, and in the middle, hidden. As we mentioned, they are connected. Some of the neuron is very important. The other neuron is not the very strongly connected. Doesn't contribute anything. As we have seen before in our brain, a lot of neurons are connected. So when we have the input, the information from the 5 sense, 4 sense, 6 sense, 5 sense, whatever. So then they will be processed through the neuron. Then the sum of the connection is very strong. But the others are not. So that can be represented by what? They are all connected and represented by the weight. So this is the weight. So some of the information are very important. The others are not. The others are yes. The others are no. So we would like to find that can ideally make the loss function error as 0. That will be this one. That idea is the same as the linear regression also. Okay? And many other, almost all the other, the training-based, the machine learning technique. So let's say this is a W. Okay? Later we have another one. So we will see. So this one is let's say W1, 2, 1. W1, 2. W2, 1, W2, 2. It's just a number. Okay? 3, 1, W3, 2. So if we organize very neat way of this, it will be what? It's a matrix. If we have the one more hidden layer, W11, 12, 13. So W11, W12, W13. So if we had more of this, W21, W31, W41. Okay? So we can represent n by n matrix. If we have n number of input, n number of hidden, that can cover general. In our case, we will cover only 3 by 2. So then 2, 2, 3, 2. So this is our weight. So which means how many weight we need to manipulate during the training? 6 of them. At least we have more. Okay? So this is the weight between this layer, this layer. Okay? Then if you take a look at the one of them, W11, W21, W31, and combine into the Z1, which means, so in the perceptron, how can we calculate the Z1? Z is the what? X product multiplied by the weight. Okay? So if we use the matrix x1, x2, x3, w11, w12, and so on, then we will have one value and two values. That will be C1 and C2. Okay? So, in other words, if we rewrite the Z1, W11 times W X will be, this will be better, X1 W11 times right, X2, this one contribute to the Z2. So plus the W21, X2 W21 plus X3 W31. So this is a C1. Okay. Similarly, we can do the C2, X2, W21, X2, no, X1, X2, W2, 2. Am I correct? Actually, this one is really better. This way. W11, W12, W21, 22, 31, 32. So X1, W12, X1, W12, X2, W22, X3, W32. This is the same as this one. So which means if we have input and initially, how do you decide the W? So you can select a random way. So select the weight function, the weight. You can select the weight, but not all 0. Why? If you set all the 0, eventually it's all 0. Okay? So it can start from the 0. So not all 0. Some of them can be 0, but close to the something between the 0 or 1 is recommended. Okay. So this is the example. Let's use the one example. We have 1. So x1 is different color. So we have the 1, the 0, such an input. So we have 1, 0. At this time, the weight is, so W is 0.1, 0.2, 0.1, 3, 4. Let's use this way as an initial value. Then calculate the C1. How much is the C1? Anyone? So 1, so 0, 1, 0, This one is a 0, 1. And this is a 0.3. And there is a 0. It's a 0.2, 0.4. So how much is that? 0.4. This one is a 0.4. This one is 0.6. So this one is 0.4, and this one is a 0.6. Okay? Then think about, can you implement this procedure in a programming? It's not much difficult, right? It's just the calculation. So you can calculate this one. Then, at this time, we have discussed about the bias. Okay? We are going to add, before we assign the value to the O1, okay? So we are going to add the bias, the 1, and bias, the 2. What is a bias? What is a bias?
Constant deviation, so I consider it as bias. There is constant deviation. So
Deviation?
I consider it with bias.
Any other?
Data is biased towards something.
Biased. Which means, it's my standard. I'm biased, okay? Because my experience, which is will not be changing, okay? So to understand, always when we talk about the baseball, okay? Baseball, because I know much about the Major League Baseball, so I usually exaggerate the quality of the player, like always 10%, okay? It's because I'm biased. So when you decide my opinion, you can always cut off the 10%. That will be accurate, right? Because I'm biased. So that is kind of a characteristic of data, because later when we adjust, when we train the data, it will be based on what? Ratio, contribution of W. It's kind of ratio. Then this bias will not be affected by the input data. Data itself, the goal, the data itself, the class itself has such a bias. So that is a bias, okay? That is the reason it's not actually affected by ratio of the contribution of this input data, instead just the plus bias and plus bias. Question, bias can be trained or not?
Yes.
Yeah.
Should be, okay? We don't know even the bias. So we will train or adjust during the back propagation. But to simplify, here we are not going to consider bias. To simplify the equation, because already it's a headache over here. But it's just plus the bias, like this one. So this is the same as what? Linear regression, okay? And the perceptron, one perceptron. So that is a bias. And also, before we decide the output value, we have applied what? Activate function. So do not delete bias 1, bias 2. So then we applied what? Activate function. So first, what is the purpose of activate function?
That was the squashing part, wasn't it?
Squash. Why do we need to squash? So always, that is the really important part, because we can think about the many different ways of the activate function. Even the last week, I have been the science fair for the middle school and high school. One of the winners from the middle school actually proposed the optimization of softmax the activate function during the neural network. The middle schooler actually submit such the project. Okay, at that time, why you need to think about why we need such an activate function instead of without such an activate function. What about the 10, 0? This value will be 4 and 6, right? So it's not the real representation of the value or weight or the something meaning. It depends on the value. But what we want to know is the eventually we cannot change this value and this value and this value we cannot change. But we can change. We can adjust this value. It's a ratio. So to focus on such a ratio, so we need to eventually goal is what? Either this or not. Okay, in terms of hypothesis. Okay, or can or the. We need to decide. So which means if we have the certain value of that, so then apply. So exaggerate the after certain value is close to 1. Otherwise it's a 0. Okay? We make it's the same idea as a logistic regression. So logistic regression need, because the linear regression, so there's no end. It can be any number, and it can be negative any number. So we don't know where it is cut off. So instead, we are going to apply such a thing. One of the simple one is like the step function. Okay, I suddenly forgot the name of this one. Step function. It's an old one. So nowadays we use this. This is the sigmoid. So sigmoid is 1 plus. So this. So sigmoid probably you learned in your calculus class. So why don't you try? So derivation of this. Okay? We will see that this one. If you have a time, why don't you try by reminding the calculus class. So we are going to apply the sigmoid. So sometimes we use the S to represent the sigmoid. Apply this sigmoid at weight function. Okay? Then because our goal is to clarify whether this value is close to which class. Okay? Close to 1 or close to 0. Okay? So that is a sigmoid function. At this time, we can use these two as an output of this one instead. We'd like to train even whether this hidden layer contribute, how much contribute or not. So we will do the same, the approach. So like this. So W, this time this is the weight, the SR is another. Whenever we have another layer during the deep learning, we have many layers. So we are going to have such a weight and calculate and train. So this is a WSR risk, which means WSR risk 1, 1, SR risk 1, 2. Similarly, we have W 2, 1, W 2, 2. What are they? These are the number, just like this one. So W SR risk 0.1, 0.2, 0.3, and 0.4, let's say. At this time, please calculate the sigmoid. So let's say the sigmoid is the symbol of this time. Which one is better? What? Usually sigmoid is this. Okay? So sigmoid function. If you do not know how to calculate that, always ask to Google. So you can search the Google. I have one. It's the sigmoid function. So this is our sigmoid function. So what is the output? First one, C1 is 0.4. So it's good. So 0.59, 0.6. So this is the 0.6. And this one. And the next one is how much is that? 0.6. So this is a 0.65. let's say 0.6. Fine. Okay. The first, not a good choice. It will take a time. But anyway, we just pretend. So this is the output. Then the next step is we can do the same thing for the next step. This step is sigmoid of the I'd like to use the same. Same one. What we do? O. Okay? Not O. The C. Output of C. Okay? This is a sigmoid. That means so 1 plus minus C. Okay? So this will be output of this one. So 0.6 and 0.65. Then apply the weight. W asterisk. So this is a 0.6 and this is a 0.65. Okay? Could you calculate this? 0.06 plus this one is 0.2. Then this one is 0.26. So this will be 0.26. What about this one? 0.12 plus 0.26. So this is 0.638. 638. So this one will be 0.38. So this is the output. You are able to calculate. Okay. Then this is you can continue if you have the more layer. Okay. You can continue to calculate the value. Then next one, whenever we have such an output of something value calculation from the layer, each layer we can apply what? Bias. So also bias, because it may have the bias for that. So we do not consider bias here. Instead, same thing, activate function. So we are going to apply the activate function. So this time it's the same thing, sigmoid. So output of let's say this output is y1 after before. So this output is an activate function. That is the O. 1/1 plus so O. We need to do it again. So what is the value? The first one, O1? 2, 6. So this one is 5, 6, 5, 6. So this is a 0.56. So next one is 3, 8. So 3, 8. This is 5, 9. So we have. So we have 5, 9. Okay, this is the output, final output after activate function with the sigmoid. So then, that's the output, the end of artificial neural network. Okay, in the artificial neural network, we can apply the multiple perceptron. Then, however, here, so to compare, we have the label, like the T. 1, 0. This one is 1, 0. So we have the true value 1, 0. We'd like to compare this one. At that time, we apply what? Softmax function. So softmax function is what? is a kind of normalized. E, the output is minus x, hopefully minus x. Sigmoid, where is the softmax function? Let's double check before I miss. Oh, we can see the softmax over here. So anyway, we need to calculate. Oh, so no minus. So x and then this is the sum of the exponent, and this is for each. Then we can apply this value 0.56 here, and this is the sum of them. So to calculate, so we can apply. So first one is what? Point. What is the value? 5.6. And next one? So softmax, this one is 0.49, and this one is 0.50. I think it's not very good choice of the W. But anyway, then we try to calculate the how much difference. This is after softmax. Idea of softmax is we try to normalize. That will be in between the 0 to 1. Some of them will be 1. Okay? Almost. When we have the multiple classes, because we are going to normalize. So if we add up, the reason why it's not exactly 1 is we ignore this part. Okay? So it will be the 1. So if we have multiple, the output of softmax is normalized. So some of them will be 1. So then we try to compare this one and the ground truth, the T. Okay? At that time, we will calculate what? The loss function. The loss function. And we are going to use the cross entropy. So idea of the cross entropy is, if it is correct, like the ideally supposed to be 1, 0, okay? In case of 1, it should be output of the loss function should be 0, right? So if we are going to use the logarithm, okay? Logarithm. Why? Why we are using the logarithm? What if we do not use the logarithm? We can use the squared, the root, the truth, output minus truth, and the square, and so on. This can be the loss function. The loss function we expect the what? We expect positive, okay? So logarithm, the reason why we are using the logarithm is the same idea, okay? Exaggerate. So if that close to 1, 0. 0 is a perfect. Otherwise, if that close to 0, so this one close to 0, that means it's a really big error, right? Huge difference. It's because it's a 0 to 1 value. So in case of 0, what is the value? Infinity number. But we don't want to minus. So that's the reason, the cross entropy. So log, the yi. So this is the y. So output, this is the y. So this is the yi. And multiply by what? The t. This t value. Okay? T. So this is the cross entropy function. So we apply that cross entropy. Okay? Which means in case of 0, this one is going to be 0. Then this is 1. The minus 1. 1 is 1. Log the 0.49. So how much is that? We need to find the logarithm function. So where's the logarithm?
Doesn't cosine have 2 negative? There was a minus 2 in the power, and then there's a minus log minus 10.
Logarithm function and function the log based on the e, and what is the value? Output is 0.49. So minus 7.1. So minus 7.1, but we have minus 7.1, so it's a 7.1. So actually pretty much big. Okay, this one goes to 0 because it's 1, 0. Okay, so this one is a 0. So the total sum is a plus actually, and goes to here. The 7.1 is our loss error. Okay, so this is the forward propagation. So any type of neural network has the same idea, such a way. So you should be able to calculate this one. So that's the one part of neural network, forward processing. Okay, then that's it. Is it the okay? It's not okay because this weight is randomly selected. We need to train. We need to adjust. So what is this loss function actually? This might be like this graph. So eventually there will be the minimum value. So we want to find the weight value that make the loss is the minimal value. So let's start here. This is a 7.1. So how can we get to this from here to here? We can by slightly change. Okay, by slightly change, we expect something next time 6, 9. Okay, by changing the 6, 7 like this. So by changing what at this time? Changing this weight W, changing bias, changing W, and changing bias. These are the variables. We cannot change this value, this value, this value, this value because it's calculated. Okay? So what we want is this one. Then how can we change? What is the idea of this one? Derivative. That's the method, then idea behind. So you are a researcher to make such a the machine learning algorithm. Then so we reaching the forward propagation. Then we try to adjust. Then what will be the idea? So we realize that we should change the value of W. Now how to change? If we know how much W11 contribute to the L, okay, then we can give the huge change. If W12 is not much contribute to the L, we don't have to change a lot, something like that, right? So if we know the contribution of the important thing of this weight or bias, any value, because they are variable, then we can adjust them to make the loss function to the global minimum. In other words, 0. Then how do we know such a weight of weight, or in other words, ratio of weight? At that time, we can use derivative. So derivative is for general. I know sometimes the explanation makes you confused because it's a little bit the next, but you'd better know. The derivative, why do we need the derivative? Have you ever think about why you are doing the calculus?
Relative to which is a zero. This is a zero. This is a derivative.
Derivative.
So it's zero.
The x squared, derivative of x squared is a 2x, something like that. The goal of mathematics is we try to understand how nature is working. Okay? What is a characteristic of nature? Okay? At that time, people decide to use a number and equation, okay, to represent the nature. That is from the philosophy. Somebody believe the fire is the basic element of the nature. Similarly, somebody believe the number is the element of the society and nature. Then if we represent anything in the world to the equation is like the what? On the Gaussian, the plane, it will be graph. So if we can understand what is the characteristic of graph or curve, we can understand nature. That's done. So then, problem is, how can we understand such a curve? How do we characterize such a curve? At that time, the people realized that this one is important. This one is important. Also, sometimes this intercept is important. Okay, this one is very similar as this one, but it's a squeeze. Okay, also sometimes this one is maybe different or the same. Then how do you understand? So we try to analyze such a curve by the ratio. So ratio is delta y, delta x. Okay, how much change the y over how much change x is a ratio. So this one is what? Slope in linear. Linear is a curve. Okay, the specialized curve. And if we have the quadratic, most important part is this one. How can we find this? The slope is sometimes 0. Then it's a plus, minus to plus. Can we find such a momentum? Okay? At that time, we can use such a derivative. Derivative is a ratio. If we apply the derivative of derivative, that means ratio of ratio. Okay? So which means, if we want to know the W11, how much contribute to the L, how can you find the contribution? Ratio. Derivative of W11. That's it. That's done. Okay? That's the partial derivation. So partial derivation, when we have a number of variables, we can only derivative for this one. Because we have how many variables? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Already 14 variables. In case of the deep neural network, sometimes almost millions of the variable. So, but anytime it's the same thing, like this one. So, problem is, can we calculate the derivative for the L directly? Not easy. Okay? So this time we are going to first find how much here the value contribute to this, which means whether we can find O1 first. Okay? Then this activate before the activate function, whether this one contribute the or not, how much contribute, and reverse way, backward. That is the reason is the back propagation. So idea is so we have this one is y. So let's say the one example is the y1. Then if we can we find this value y1? Yes, we can calculate this because we have the softmax the function. Probably I erase it here. Softmax function we can we can derivate it. Then we can get the derivation of this one. Actually, if we calculate, I'm not going to this in the whole step. Instead, over the winter spring break, I calculate that this one is the minus T1 Y1. like this. It's very simple because it makes sense. This is a derivative of the softmax. Softmax? Oh no, not softmax. Cross entropy. So cross entropy, because we calculate this one cross entropy function, that is the minus t the I log the yi that we calculate. Okay, so this is the loss function. So if we derivate, so you can derivate the this one y, then the ti and the log will be 1 over yi. That is the reason t1 y1 in case of 1. So you are able to do it. Okay, please do your homework at home. So you can the derivative by the yi. So this is the constant. Okay, log is 1 over the variable. So that is the t1 over yi. So we know this one. Then next, the next one is we'd like to know the softmax, the derivation of the softmax. At this time, I'm going to instead, because it's huge, so I already made the before that. So we know, so here, let me erase, we don't need the number right now. So this is the cross entropy L, Y, I. Okay, so we can calculate this one from L. So we know how much the cross entropy to contribute on the loss function. Then the next thing is we want to know for L, the B, the I. The BI is the after activate function. Okay, after activate function, the value BI is how much contribute this one. At this time, instead of directly the derivative, the L by the B1, BI. So actually, this time we can use this. So we already know this one from here, calculated. That is this. Also, from this is the softmax function. So we can the derivative softmax. So actually, softmax, if you the derivative the softmax function, it will be like I will show you. Yes. So this is the derivative of the softmax. In case it's true, whether output is the same thing as the class, then it's I equals A, then this is the one, and otherwise this one. So for example, we can calculate all different cases. So we know for example, one of them, we know minus y2, y1. So we can apply this derivative to here, and we can calculate from this. We don't have to calculate it here. Just calculate the softmax the derivative. So that is this one. Then if you see this, we can delete. So this is actually what we want. So this is called chain rule. So using chain rule, we don't have to calculate one for each. Okay? Instead, by backward, calculate the derivative of this. calculate the derivative of only this. Then apply the chain rule. So we can get the value of derivative. Similarly, the next one, O1, we don't have to calculate the derivative of all this using the previous one. We already know that this. Then BI, OI. So we can calculate the derivative from here. Okay? Similarly, if we calculate the LW, we don't have to calculate again the using this. Then apply. This one is actually simply very simple. So we can the derivative, then x1 is the derivative. Very simple. So then similarly bias is the same thing. The bias is a plus. So all the other will be 0, only bias is a 1. Then we can calculate. And the W1, same thing. So back propagation, using the chain rule, it will be very straightforward calculation. So let's see the next step. So this slide, to make this slide almost a day. So this is the result of the forward propagation. So we have the L loss function. So we try to find how much contribute each variable. So first we can calculate. Which one is? So we can calculate the loss function derivative. Then we can actually derivative softmax. Then using this one, we can apply the chain rule. And similarly, we can calculate instead of calculating derivative of the L over O, we can calculate the B over O. And similarly, the W and the B and the C and the W. We can continue backward. So if you actually really calculate the value, it's simple. This one looks like very complicated. If you calculate the value, that example is in the last week, the lecture note. Okay. So for example, this is the derivative of the loss function, and this is the softmax. So we can combine this one and this one to get the derivative of L over the B. We can combine these two. So that is this that we can calculate. So very simple, the output. Similarly, so we can continue the sigmoid. Sigmoid is this, if you the derivative. So we can apply this to calculate. So to calculate the W, the S service, we can, instead of calculate all of this, if we already have the previous value, we can just derivative that function. W is if you, the derivative W, actually it's x1 or the x2 or x3, such a value. So then finally, this is it looks like very complicated, but we already calculate the previous layer. So we can just multiply and by the derivative. So like the last one, this one. Okay. So this one and this one, this one and this one, then we can get the derivative of the W11. And we can do the next thing, then finally we get. At this point, so finally we got the delta W11. So let's say this is the 0.11. Okay? So we can get the value. Then, how can you apply such a delta to adjust? So as we have learned, x plus delta x. That's our board. Okay? So let's say minus. So then, if we apply this one and reduce, it continue to this one. Sometimes this value is really big if you have the 100, 200, even though we apply. So we try to give something ratio, so reduce. So that is called the we can apply something, the constant value. This is called the running the rate. So running rate, you can apply like the 0.101, reduce. Otherwise, it can be jump, like this. So not too much value. So you can just specify the, if you reduce, that will be like a little bit. That is the gradient descent, the algorithm. So using the gradient descendant algorithm, we can train. So when you train the network, so we use the back propagation and gradient, the descent, the algorithm. At that time, sometimes even the gradient descent is small. So we try to test 10 or 100 the input data together. Then combine such a loss, first loss, second loss, third, fourth, and 100 as a batch, then apply to here. That usually works better, so that is called the stochastic. Stochastic, the gradient descent. The stochastic gradient descent algorithm. Okay, so any questions? That's the overall thing, how backpropagation is working. In terms of programming, it's not very complicated. The problem is, when you have the very large number of inputs, you may have a lot of W, and most of them are what kind of computation? It's a matrix computation. Multiply, plus, multiply, plus. So to address that problem, so tensor is a set of array. So instead of in terms of instruction level, like the processor, so if you already took the computer architecture or the microcontroller or the operating system, if you implement this one, your high-level programming Java or Python will convert it into the instruction level assembly. The instruction level has a lot of add operation, a lot of the multiplication operation. So that repeat. So instead, if there exists the batch operation for this one, that is the GPU. So GPU actually processes graphic. Graphic is the array, like the row and column graphic. So they dedicate their instruction are dedicated to such an operation. So this one is perfectly fit to such an operation. That is a GPU. That is the reason we are using the GPU for deep learning. Another thing, the tensor is the data structure to fit the GPU. So set of such an array, multiple high dimensional array, set of array. So by defining tensor, so we can have the simply represent one layer, even the W and the so on. Okay. So that is the overall thing. Any questions? Please review again in the slide, so then you don't have to memorize. Please try to understand such a flow, the theory of that.
Is your example code too in this other and
Which? This one?
or anywhere on Canvas?
Oh yes, it's already uploaded to the canvas, so you can find this. Currently, we will see the next. Yes.
For cross entropy,
Cross entropy. Yes.
yeah, it's Ti log Yi. So
Here, Yi is the output of the softmax. So to calculate such a Roche function, the cross entropy actually minus negative logarithm. That is the cross entropy. Then summation.
okay, Ti here is 1 and 0.
Ti is the true value label.
Okay, so in this label 1 0, so
Yes, so for example, in this case, 1 0. 1 is a dog, and this one is cat. So dog, this one is a dog data. 1 1 0 is a dog. So output what we expect ideally 1 0.
So
Okay.
for the 0 it will be 0, so how it will be contributed?
So this one is not actually the neighbor. That's the reason. This one is called that's a good question. It's a one hot vector. This one is one hot vector. Okay, so what we want is the weight that contribute to find this door. Okay, so 0 case we ignore. Some of the data has 0, 1, right? At that time, this the variable that contribute to this one will be adjusted. Okay, yeah. So because that is one idea of the the reinforcement. Reinforcement give the something, the reward for that and some compensation. So at that time, this one, the negative case, something, but in this case, we are going to adjust that is the true, the 1, 0. So that is actually the cross entropy.
And instead of mean square, we distributed for both.
That is the loss function. So I forgot the name of the root. Logistic. The logistic, the loss function, logistic loss function used such a negative the -2 minus output and square. At that time, this one will be also considered, but the logistic entropy does not consider the 0 case, which means not the matched one. Okay, so you can see the details of such a logistic function. Here, so in case of same thing, the different thing, and you can find. And also I put the example in the last slide. Where is the? Yes. This is an example how to use the cross entropy function. So this one is the label, in this case a t. Okay, so it's a 0, 1 means this one is not, this one is true, so minus log 1. So in case of 0, it will be the 0 value. Okay. Any other questions? Okay, so the next class we will see the recurrent later. There's a second wave of AI winter after backpropagation. As you can see, probably it needs a lot of the computation, right? So at that time, around 2000. Before 2000 and after 2000, the backpropagation was not well recognized because it needs a lot of the calculation. So it's called the second wave of the AI winter, but with the help of the GPU, and later it is coming back. So right now is the kind of era of the deep learning. So what is a deep learning? It's not only just one layer, it's the huge layer of the processing. So that is the reason it's called the deep learning. There are different the networks, so we will see the sum of them. So AlexNet is one of them. It's the part of convolutional neural network. It's actually the based on the Lacan, the 19 is old, but the classical, the convolutional neural network, but it improved a lot of huge accuracy. So for example, this is basically two set of layer. So one set and another set eventually later is combined. We will see it a little bit more later. So nowadays, the layer is deeper and deeper. So this is an example of the one proposed network in the 2015. So 150 layered network. Currently, so we have better the hardware. So more powerful hardware and bigger size of data and better regularization. Regularization is kind of the smoothing to avoid the overfitting. So overfitting, so we trained well. So like the data is like very detailed. But what we want is like this. So we try to apply the smoothing technique to regularization. So this is, so you can understand the regularization as the smoothing. Dropout is the, think about, if you have the too many choices, when you decide something, it's too many options, too many the variable. It's very hard to decide. So to address that one, you can just ignore some of the data. Okay, just focus on the half of them or the sum of them. So that's the similar idea. So if we have the deeper the network, just ignore some of the node. Okay, sometimes mostly randomly. You can ignore that. Sometimes it's better. Sometimes not. Sometimes always better output, because not only, even though this one contribute a lot, this one is not the only one. Okay, there exists other node, the variable that contribute more. So if we take out half of them, half of the node, then the accuracy is better. So that is the idea of the dropout. So dropout the randomly, the drop out the certain percentile of the node. We don't have to verify whether this node is good or not, just randomly, because there exists the node that contribute the the accuracy. So we can classify the deep architecture, the neural network, forward wave, feedback, the bidirectional. We will see later. Okay, so there are a lot of tools that once you understand such a fundamental of the neural network, then you are able to implement your network. So to do that, TensorFlow is popular. We are using Keras is also popular. The difference between these two is Keras is higher level programming to help you guys. Okay, even though we do not know the details of such a processing, select something sigmoid. Select the activate the loss function. Then select the number of layers that train model. So it's a very high level the program. TensorFlow is kind of the, as I mentioned, is the kind of hardware, okay, to process, okay. So then based on that, the Keras is running on top of this kind of the library, okay. It's not really low level processing, but lower than this, okay. So you can do the programming using TensorFlow only. Sometimes much better to understand the theory of such a thing using only TensorFlow without the Keras. But for you, if you do not need such a details, you can start from the Keras. And similarly, we have such a the deep learning framework. There are pros and cons. I'm going to skip this part, but you'd better know the black box means it's a higher level the programming. You don't know what's going on inside, but easier for your programming. But on the other hand, the white box is you need understand such a details. Then if you are focusing on the research on such a machine learning and so on, definitely you'd better know. You should know. Otherwise, if you are interested in how to apply the deep learning for the specific domain, specific problem, the black box is okay, the higher level. Okay, so let me stop here. We will have the 10-minute break, then continue for the convolutional neural network.